All right, we're going to go ahead and get started. First of all, let me thank you all for your time today. I know you have a lot of different choices to go to here at reInvent, so thanks very much. If we could ask one favor of you, my manager won't approve my expense report unless I do the selfie thing and get some people that either pretend to look interested. So if I could ask you to come up here. I do not want to pay for this trip, so.
Oh yeah, the airfare is expensive.
Look excited. Look excited. Stop that. So thanks again for coming. My name's Wallace. This is Orion. We're going to spend some time with you today to talk a little bit about our life and operations, cloud operations in AWS. This is Orion. $5 to the first person after this session who can pronounce his name properly for me. I'm not going to tell you how to do that. Orion is a cloud operations engineer with a group called AMS, AWS Managed Services. I've got a couple slides in just a minute to tell you a little bit about what that group is, what our group is. One interesting fact about Orion is that he speaks fluent JSON. And when I say speaks, I literally mean speak. So if you want to have some fun out in the hall afterwards, ask him to tell you his favorite I am policy. He'd probably be able to do that for you. He's also super well read, so I'm going to call him on some words that he's going to use today because I'm not going to know what they are. I just guarantee you it's going to happen here. So, Orion, anything you want to add to that?
No, I think that's a wonderful introduction, if a little flattering. Thank you. I'd like to introduce my program manager, Wallace Simpson. He brings decades of experience to my years of operating in ITIL-based on-prem situations. And we're going to leverage a lot of that experience in telling you a couple of stories here.
That's absolutely true. Over 20 years of enterprise IT ops, so of course I'm fluent in ITIL compared to his JSON, and we still get along.
They're equivalent.
So I've been at AWS for 2.5 years. I'm a technical program manager in operations, and I look after the global operations team for our group. And really my whole life is about continuous improvement to make sure that everything that we're doing as we deliver the AWS Managed Service gets better every single day. So with that, let me tell you a little bit about what AMS is, or AWS Managed Services. We deliver AWS Infrastructure Services to some of the largest enterprise customers that AWS has. We do that by delivering cloud-native AWS services and also management tools. But on top of that, we've built some management tools, some automation, some operations, and all of that is backed by people. And we really draw the line at the infrastructure, and then customers and their partners of choice really own the application above the infrastructure stack that we manage for them. So all of the app dev and the app management and app support is done by customers and partners, and we do the infrastructure down below. That's the marketing speak I was forced to talk to you about. The net of it is we run AWS cloud infrastructures for large enterprise customers. We've been a GA, we've been general availability for about 2 years, growing super rapidly. If you want to hear more about our group, happy to talk to you out in the hall about it. We also have a booth in the very back of the expo hall. Go all the way to the back, and you'll find our booth in the back. Now, when I say we deliver infrastructure IT operations for customers, what that really means is we enable provisioning of AWS resources. We enable change management to those resources. We provide access management. So really the model is there's no access until you request it. We do alerting and monitoring and logging. We do alert response. We do security response. We do incident response, and our incident response has initial response and resolution SLAs. We do patching. We do backup and restore. So anything that you would think of in terms of IT operations for an infrastructure organization, we do for our enterprise customers. And really the reason that we do this is so that they can focus on what they want to focus on, which is generally application innovation, and not have to worry about the infrastructure. That's really what we do for the group. Some housekeeping notes. I see a couple cameras popping up. That's cool. It tells me which slides you like. I need to tell you that all the slides are going to be available after the presentation in some form on a SlideShare or something. I'm sure you're going to get one of many emails about that. And the talks are also going to be available on YouTube at some point. I can't wait for that.
Comments?
So, Orion.
Yeah. So when we're talking about cloud operations, that can mean a lot of different things to a lot of different people. And some of those people are my friends, and they have certain things that they think I do. And then some of those people are my parents, and they have some different things that they think I do on a daily basis. And there's some different perceptions from the customer's perspective, and a certain relationship that my vice president seems to have with me, and then a snapshot which is not entirely accurate here because I don't wear my shoes that often in the office
It's true.
from what my manager sees. But then we get to what it actually is. And when we're talking about what cloud operations looks like, we find that a lot of the stories and a lot of the processes that we're dealing with to resolve incidents and manage infrastructure on behalf of our customers are really the same models, the same kinds of stories that we've been telling for years and decades in the IT space, but with a little bit of a cloud twist, with some different tools and some different processes. And so we're going to go ahead and walk you through some of those today. When I started at AMS, Wallace and I got to talking, and we got to telling a couple of war stories with each other. And we found out that really these war stories we were telling were the same stories. So I was going and solving something one way, and he had gone and solved it another way. And when we realized that they were analogous and that this was a relationship we could establish, it turned into a long conversation and eventually a talk, which we're going to present to you today. So the rules of the game that we're giving you today are that these are all real stories that we've actually dealt with. They are roughly organized to follow the life cycle of applications as they become more and more mature, but are not necessarily completely chronological. And the final rule is that there's a lot of mess and things are going to get bumpy, and hopefully we'll solve all our problems.
So what Orion just said was pretty interesting. When we were having those conversations, I was relating back to my 20-plus years of on-prem IT operations, and he doesn't have 20 years of on-prem IT operations experience. And like you said, the situations were very much the same, but the way we dealt with them in the on-prem world and in the AWS world were very different. If you like that idea, there's some talks here at the reInvent on enterprise DevOps. It's a thing that we've been working on in AMS and AWS. And the premise, very quickly, is if you take the best of ITIL and IT service management and traditional IT operations, by the best of that I mean things like security and governance and compliance. And then you take the best of the DevOps world, which is agility and rapid innovation and value. Those two are actually quite compatible and work together very well if you're willing to let that happen. So if that sounds interesting to you, look for some talks on enterprise DevOps, either here or afterwards, and you'll hear more about that concept right there. So, you ready to do this?
Yeah, let's do it.
All right. So, in this first scenario, you've got users calling the help desk, absolutely screaming that their application is down. And we're in IT infrastructure operations. And tell me if this sounds familiar. Hey, you just got paged for an application that's down, and it's an application you've never heard of. Has anyone ever experienced anything like that? Yeah, fairly common, right? So the first thing that you start to think about is, I don't know what you're talking about. I think in terms of servers and networks. I don't know the application. I've never heard of it. There's no documentation on it. I don't even know where to begin, but there's one thing that's pretty sure. They expect us to get it back up and running very quickly. So that's the scenario that we want to tackle on first. And in my years of experience, we took probably a less efficient path towards this. There's a term that I've used for many years called tribal knowledge. And really the concept there is try to find the people who know the most about the thing it is that you're looking for. Sure, I've worked in many organizations that had ITSM systems and configuration management databases, and I am a full-on supporter, ITIL geek, in all of that. But I also clearly recognize the on-prem challenges of keeping that information up to date and current and accurate and really, frankly, trustworthy. So because it was less trustworthy, what we would typically do is start chasing down the people who had heard of the app, had met somebody who had heard of the app, had remembered anything about it, and now, frankly, we're trusting that we can find those people and that they remember anything about it. And then once I find those lucky people, I'm going to pull them off of whatever it was they were doing, which was also really important and most likely firefighting related. And then I'm going to put them on this thing so that I can get them to work on the infrastructure, bring the application back up as fast as possible so that I can let them go back to the other fires that they were fighting. And because we're in the business of firefighting, we're not going to really be able to take the time to do a full-on post-mortem to see if there's anything that I could do to improve the situation next time, because I just don't have the time. Best intentions, no time to do it. So again, does this sound at all familiar with any of you? I mean, right, I see some heads, yeah, okay. So this is the way that we would have done it, I don't want to say back in the day, but I will, in an on-prem type environment. So Orion, tell me how life is a little bit different in your world.
So when I got this page, I had never heard of the application before. I had no idea what it was. And all I had was the name. I didn't even really know what it was serving, like where. And so I hopped into our federation system, and I found an account that had the name of the application in it. It was all I had to go in. So I went ahead and logged in. This is the first time I've ever logged into this account. It's the first time I've ever explored anything here. No idea how the application works, what kind of infrastructure it's running, or where it's running at all. I don't know the region. And so I go to the actual white-hot core of any AWS account, which is a surprising starting place for a lot of investigations, but it's a really powerful one. See, I had read-only access to the billing console, and that gives me the opportunity to go into the Cost Explorer. And when we go into the Cost Explorer in the billing console, you can break things down by region. Once you do that, you know, oh, hey, this is working in US East 2. At least I know where my resources are located. I can start to look at them from there. And you can then break it down by service, and you can see, well, in this case, I found out that I actually had a lot of resources running in ELB. And ELB is usually a pretty standard entry point. Sorry, Amazon Elastic Load Balancer. Yeah. Is a pretty standard entry point for any application. And so I just went ahead to the console and I took a look at what was there. I found something really interesting while I was in the load balancer console in EC2, which is that there was a stack ID tag from CloudFormation on that load balancer. Now, you usually think of CloudFormation as a deployment, infrastructure as code, and DevOps tool, but it's actually really, really invaluable for operations engineers and incident response, because it leaves a lot of crumbs around, and it provides you the investigative paths for you to figure out what's actually going on. Because once I had this stack ID, I could hop over to the CloudFormation console, and I could actually take a look at all of the resources that were going on in that same application. Once I see that, I can start to look at the weak links there. I can start to look at the things that may be causing issues. And so I just started exploring through. It was like, well, there's security groups. Those are probably going to be fine. The load balancer looked healthy while I was looking at it, but I've got a couple of EC2 instances. And so I went ahead and looked at those. I found that health checks were failing on one of those, and bringing it back to what I actually do, once I had located the problematic resource, I gave it the old stop and start, which brought the instance back into operation, and the application started working, which resolved that our issue.
Cool. So one thing that struck me when we talked through this scenario was, in the on-prem world that I come from, procurement and operations are driven by two entirely different organizations. And just the idea of going back into purchasing or billing information to determine what resources are actually running in a data center was just foreign to me. I've never experienced that. I know some organizations have tried to do, asset management and inventory management, but the story is very similar to the CMDB story, which is, how accurate is it really? So I found that to be pretty interesting. And of course, AWS is going to bill you, so you know that that thing's going to be pretty right. The other thing that I found interesting was the deployment story of using a deployment tool like CloudFormation as a way to scope out the application and the resources that were being used. Again, I would have gone to some sort of imperfect CMDB, or I would have tried to find people. So you'll notice a trend in this and some of the other stories. In the on-prem world, we were focused more on people and process because our tech agility wasn't really there. And the data we were looking for wasn't really there. And the stories have reversed, where now Orion can go in and start thinking about using the tools at hand and not talking to people, because frankly, he's not very good at talking to people.
It's true.
So does that story sound somewhat familiar to you in terms of doing the recon on the assets that are making up a service, and then trying to find the context, find where to tackle the issue?
Yeah, and another trend that you're going to see throughout this and throughout our careers is that a lot of operations is investigation. And so you're going to see a lot of detective work here, which is where a lot of these services provide unexpected value.
So with that, let's move on to the second scenario that we wanted to talk to you about and share some ideas with you. And this one's fairly similar to the previous one in that there's an outage, but there's one slight change in this one in that I know that there was I'm going to call it a poorly managed change. Does that phrase sound familiar to some of you? Right? There was a poorly managed change that led to the outage, and now the detective work is not just what broke, but why and how, and maybe a little bit of who, but less so on that. But the situation is very similar. I know very little about what's happening and have to do some detective work. So I will still take the people-centric approach. I'll still do the tribal knowledge. I will dig into my ITSM change management module. I'm hoping that an RFC or a request for change had been submitted and potentially approved and well documented with things like the backout plan, so that when it creates an incident, we just execute the planned and documented backout plan. How many have lived that life of a well-documented backout plan that actually worked? Okay, that's cool.
Wow, there are hands.
I saw a few hands there. My experience, sadly, had been a lot of backout plan tested to fulfill the required text field that goes into the right. So it was still the same sort of situation of detective work, and now really, the first question we always ask in support is, well, what changed? And nobody's going to say anything. You're going to try to do this in a non-finger pointing blamey way, but who's going to fess up and say, I'm the one that did that and took the whole app down? Yeah, it doesn't usually happen. That's a cultural thing that is pretty universal. There's some special cases where not so. But anyway, it's the same sort of tribal knowledge, people-centric, process-oriented detective show to figure out what happened.
So when I'm walking through this process, I want to first just stop by some of the low-hanging fruit here, because there are a couple of services that if these were used in the application's development or deployment, they can make this process like almost too easy. So if the application has been deployed through AWS CloudFormation or Elastic Beanstalk to deploy it as code or to manage the pipelines that are going to send it out, your job is essentially done for you because you know what the application is supposed to look like. And there's a little bit of an advantage here from a very recently released feature from AWS CloudFormation, which is drift detection. It's very, very exciting. It will tell you whether or not your resources are what CloudFormation thinks they should look like. And additionally, AWS config, if you've defined configurations in AWS config for your applications, then it's not only very easy to find out what's gone wrong, but you actually probably got alarmed when it changed. But I was not so lucky in the case that I'm going to describe for you. I found out that a change had been made, and I had no idea what was going on. None of these more advanced deployment or application management systems had been used, and so I had to hop into my personal favorite service, AWS CloudTrail. So AWS CloudTrail is a very, very powerful auditing tool. It's a record of the API calls that are made against AWS, which if somebody logs into an instance and runs some commands is not going to show up in CloudTrail because it's not an API call. But other than that, any infrastructure changes, the kinds of things that infrastructure engineers like ourselves might be dealing with, those are going to show up there. And so in this case, I was a little bit more fortunate than previously. I'd heard of this application before, and I'd actually even seen it. And I knew that there was supposed to be an EC2 instance in this account. And when I looked, well, there was not. And obviously, that's going to be a problem. So I had to start digging into CloudTrail. Now, I want to say that there's a lot of ways to consume CloudTrail. You'll see a lot of people using Amazon Athena. I myself have the most embarrassing piece of code I've ever written, which is a 700-line and growing file called cloudtrailstuff.py. And so you'll see everybody dealing with CloudTrail in whatever manner they want. But today I had a pretty simple query. There's only really one way to get rid of an EC2 instance, and it's with the terminate instances API. So somebody had called EC2 terminate instances. I could find that in CloudTrail. I didn't even have to hop onto the command line. I could do this straight out of the console. And so I go in and make a query against that, and I find the responsible party. And it turns out that it was an instance role attached to a CI/CD server, which I'm actually going to talk about a little bit later on. But once I'd found out what was going on and I could remove the permission to manage that, I then had to start into the process of disaster recovery because we had an application running. It was not a terribly well architected application. It was running on an EC2 server, and there was live data on it, and we needed to get as much of it back as we could. I was fortunate in this case because we had set this application up with some EBS snapshots, and so I was able to recover a snapshot for the instance. Finding it was actually a little bit more of an adventure because as many of you probably know, when you terminate an EC2 instance, it will destroy the root volume. However, if you have a snapshot, the snapshot will remain even though the volume itself is gone, and it can be restored into a new volume. So what I did was I made a couple of queries against the AWS Describe Snapshots API, and then I mapped the volume IDs onto Describe Volume APIs, and eventually I found one that didn't have a volume attached to it. And actually, I found many that didn't have a volume attached to it, but they were all sequences off of the same volume. So I took the latest one, I restored it, made a volume, launched an AMI, launched an instance, and with about 8 hours of data loss, we had the application back up and running.
So you've talked again about using some deployment tools as a way out of the jam to find some context. One thing, and of course, CloudTrail being the ultimate source of truth of what happened in the account. Coming from an on-prem life and world, I always thought it was interesting that when an admin in an on-prem environment was doing things to stuff, very technical speak, it's very difficult to figure out what it actually was that they did. Unless you started to aggregate a bunch of logs from a bunch of different places, they could do pretty much anything, and you wouldn't really have a good sense of what they did as compared to the CloudTrail story that he just told just a moment ago.
When you talk about it as a source of truth, I'd also like to bring up another point that's really salient for managing CloudTrail, which is that CloudTrails are immutable. You can turn them off and you can delete them, but you can't edit them. And so you know that if there is a CloudTrail in the right region that's monitoring what's happening, it's not going to be missing events because someone went through and did something embarrassing and decided to clean up after themselves, or worse, something nefarious and decided to clean up after themselves.
So really, the story that Orion just told us was, with a lot of these AWS services and features, it's now much, much easier to really get to the root of that poorly managed change and exactly what happened fairly quickly. I remember back in the day, the guidance was, well, you've got your CMDB that you trust. Go do a physical audit of your data center, compare the two. If there's a delta, you've got unmanaged change happening. Very few organizations were able to do that with any success to highlight anything. And if you did, you're talking months or years between the actual change that took place and the detection of it. Here, with things like CloudTrail, AWS Config has a recorder feature that essentially records changes as they take place. And Orion also mentioned a newly released feature in CloudFormation with the drift detection. And if you haven't checked that out, I highly encourage you to go check that out.
It's pretty cool.
Where you literally just say detect drift, and it'll come back and tell you the JSON, which he could parse for you. It'll tell you exactly what has changed since the CloudFormation script actually deploy the environment. So pretty cool stuff. Let's move on to another scenario.
Yeah.
This one is a little embarrassing. If you've ever been administrating some sort of server or network gear, and you do that unfortunate either configuration change or file deletion or some other fairly innocuous but stupid activity, and you get that pang in your stomach and you think, oh crap, what have I done? And the reality of the damage sets in, and you realize, I can't get back into this asset. I have locked myself out of this thing. I am not going to get back into this. I'm not going to ask for a show of hands on that one. So yeah, there you go. There's one brave soul. So in this particular case, in an on-prem life, did it advance?
This is the one with like a bunch of clicks.
Oh,
Yeah.
Thank you for doing that.
Yeah.
Somebody's PowerPoint challenged.
I'm not good at PowerPoint. I apologize.
So in an on-prem environment, the first instinct that we would have when locked out of something is, I need some sort of physical intervention to this thing. I don't know if you had crash carts in your data center with serial cables, and hopefully that crash cart was loaded up with the right tools and files and code and symbols and all that kind of stuff. And you would, well, first of all, you got to locate the thing that you broke. Let's just not overlook that that might not be an easy task in itself.
Right.
So you got to locate the thing. And by the way, I hope that thing that you broke is in the same city that you are. Or if it's in another city, that there's somebody in that city with the skills that you trust and the crash cart that they could go and do some sort of physical connection to it. And then you start poking around and seeing if you can get into it in some nefarious way. And then, of course, we always have that guy or gal who knows everything in the office, and what I call the informal escalation of like, hey, Fred, I did this really stupid thing, and I deleted this, and I'm locked out, and boy, it would be really great if you could help me out and tell me how to get back in this. And he just kind of looks at it and you go, yeah, no, dude, you're in trouble. So that's not going to work. And then he might suggest, maybe you should call your vendor support. Maybe they can help you. Maybe not. And then lastly, you're in the back of your mind, this is always going on like, yeah, I'm going to have to yank some drives and rebuild some stuff and reconnect some stuff and try to explain this away as, I don't know, some DR drill or so. I don't know. We're gonna try to figure out a way to get through this. But you know what you did, and it's going to cause. The bottom line is this is a major headache that you've just created with some very simple thing that you've done. So that was been my experience in the on-prem world. Talk to me about AWS.
So the first resolution that you had there is actually essentially what you would want to do in on-prem, because your first instinct is right. You want to get your hands on the machine, you want to connect in, throw a console cable on it, yank the drive and fix whatever you did and then put it back in. And fortunately, AWS has a lot of analogs to physical access that you can take advantage of through APIs. And if anybody has security feelers that are starting to wiggle here, I will talk about security regarding this access in a minute here. So the first thing that you want to do, let's say you have accidentally pkill SSH'd thinking you were going to kill an SSH session, and turns out that SSHD matched that regex. I'm sure nobody's done this 2 or 3 or 5 times.
You told me you've done it a couple times.
Once or twice, yeah, a couple. So the first thing you want to do is you want to go ahead and just run a command there. In this case, you're dealing with something pretty simple. You just need to start SSHD. And so the service for you there is going to be Service Manager's SSM run command. Run command is essentially root level access to your machine governed through an API. It goes ahead and it sends a communication out to an agent running on the system. The system executes that on a local user that is set up during the installation of the agent, and then it returns the output of the command that you sent to S3, and ultimately also to the SSM API where you can retrieve the command output. It's very powerful and very, very, very useful. It's also really powerful for automation. Now, sometimes...
Before you move on, how many people here have used SSM run command in the sense that he just described here? I'm just curious. Just a handful. Cool.
Interesting.
Great. Keep going.
Yeah, and so SSM run command is really powerful and is really, really, really well designed for automation. But sometimes you actually just need a shell to interact with the machine. And if you were connecting in with a console cable, you would be going in and playing around, finding out what you did. You really messed up SSHD config. You ruined your networking setup. You need to generate a new key pair and install it on the machine. Whatever it is that you've done, and you need to play around for a while. And that's where SSM Session Manager comes in, because this is literally the only slide that we include that includes my browser on it. Because you can see that is a shell running in Firefox. It's really, really nice and easy to use. I've actually dumped the environment variables that you'll see there. Again, it runs as SSM user, which has the permissions to run root level access. And again, I'm going to talk about the security model here in a second. The last intervention that you'll want to do, and this is always the ultimate break glass, is once you find the machine that's broken, you crack the case, you pull the hard drive, you fix it. And in AWS, you can do the same thing. Prior to my finding out about SSM, I had used this method a number of times to solve my problems. So you can go ahead and just turn off an instance and yank the root volume, and then attach it to another machine, mount it, fix whatever you've got to do, disconnect it, reattach it to the initial instance, and boot things back up. Now, I wonder if anybody has thought of the one thing that any good operations engineer should have done before they did any of that. Take a snapshot. You always want to take snapshots when you do this kind of thing, in case you break things worse or you need to do some data recovery. But yeah, essentially you can go ahead and break in and solve these problems just like if you were physically next to the device with a crash cart, with a laptop and some serial cables or SATA cables or what have you. But coming back to the security model here, that's actually kind of a scary thing that I just said, that there's a way for you to go in through your browser and essentially gain physical access to your machines. And that's where the AWS security model becomes really important. Because first and foremost, all of these are API commands, or API calls that are governed by IAM. And they're actually governed with a strong level of granularity. If anybody's not familiar with IAM, it's the Identity and Access Management System for AWS. It is how you are going to manage who can do what in your systems. If you need somebody to be able to administer a couple of instances, it's possible to write IAM policies that will allow them to use run command or session manager, or even the ability to disconnect volumes specifically from those instances and from nothing else. And additionally, if you think that this is just a scary and terrible idea, and you don't want to have these shells anywhere near any of your instances, you can either not install in the first place or uninstall the SSM agent, and then this whole system doesn't work at all. Because it's really just a local agent that is listening in a protected manner to the SSM endpoint. Yeah.
Great. So continuing the trend of being able to dive into the tech very quickly, do the thing much faster and easier. In this case, what I heard were some literally break glass entry points that have that fine-tuned grain control of who can do what. But be sure to remember, either turn it on, install the agent, give access, or not, if that's your intended outcome. All right, let's move on. I've got a couple more scenarios we want to go through. This is one of my favorites. So in this particular scenario, you've got an organization, probably a shadow IT organization that has
Sorry, what's a shadow IT organization?
Oh, yeah, forgot. Yeah. So shadow IT meaning a parallel or non-centralized IT organization that has grown up most likely in a business organization or business unit, usually because of some sort of dissatisfaction with the central IT that they're not moving as rapidly as the business would like to. Good?
Yeah,
okay.
Yeah.
So in this particular scenario, a shadow IT organization has decided that they're going to put some super business critical app into production, And what they've done is they've literally hijacked your disaster recovery environment, put the app on it, and then declared, we're in production. I don't know, this one's a little bit rarer than the other scenarios. Has anyone had this happen to them, where something was suddenly dropped into production? Yeah, okay, good, there are a few hands here. Yeah, it's not the most pleasant place to be, where there are a couple different problems that are going on in this space. The first one is, you've got to figure out, as an IT, as an infra IT org, how you're going to operate and support this thing that day. And now we're talking about, well, I'll get to what we're talking about here in my on-prem response. The second thing you have to deal with is, by the way, you just lost your DR environment. Congratulations. So in the on-prem world, what we would do is we would focus on the first thing, which is, how am I going to support this thing? And again, it's often a lot of process and policy and people. How I got to configure my tools to accept cases for this new app that I've never heard of. I've got to find people who have any expertise at all to support it. Or if I'm brave and can get away with it, I'm just going to punt all app issues to the business group that did this thing. And then later, if I've got time, I'll try to figure out the DR scenario. But I don't know if you've tried to procure hardware and software in an on-prem environment. It's not the fastest thing that you could do. I don't know, 8 to 12 weeks. It's kind of like the shuttle from the Venetian over here. If you're in a hurry, you should rethink that. Sorry, AWS gods, please don't get me in trouble for that. I'm probably never going to speak again.
No.
Okay.
Us both.
Yeah. So we've really got to figure out these two problems of how I'm going to support this thing, because now it's it's mission critical, but also how am I going to recreate this DR scenario? Yeah. So how would you do it?
So how I did do it actually came down to a slightly different scenario. It was not something that had its DR removed. It was something that had never been in prod before. We had a development and test environment, which I, again, had never really seen, never really heard of. And suddenly this was an application in production with no disaster recovery, only one dev environment, no test prior to production, and no operational readiness on it whatsoever. And I find out about it because it's down. Now, as it happens, it had gone down immediately after launching, which is, good. At least we're finding out fast, right?
Fail fast.
Right. And so I got lucky on this one. Since we were doing the deployment, I actually got to talk to the developer who's managing the application deployment. And we started to look at it and see what was going wrong. Now, he came to me and said, hey, this is down. I need help. I need to solve this problem. And so we went, first and foremost, to Claude Watch, because EC2 actually gives you a lot of data right out of the box. And so I believe the graph on here is just network in out. It's nonsensical, but in this case, we ran into a situation which doesn't graph as well, which was the fact that the CPU was at 100% and the CPU credits were at 0, because this developer had launched it on AWS T2 instance, which is a CPU credit-based system, which means that it's really good for some bursts. It has enough throughput to get you through any basic workloads, but if you have something that's going to be delivering a lot of content that's going to be under consistent load, it's eventually going to run out of its credits, and then you're going to be at a relatively throttled CPU rate. So once we realized that was what was going on, we made the responsible infrastructure decision here to move from T2 to an M4 instance, and these days you would actually use an M5 instance, which is not a metered instance, and therefore you can use the CPU as much as you want. We went ahead and put an alarm on that particular metric, the CPU rate, because we've seen that this is a pain point for this application. This is a situation in which we might want to increase it later, or, and we'll get to this in a little bit, where we might want to key some other automation actions off of that particular metric. So after that, we addressed another pain point that we discovered during the investigation here, which was that since the instance had no available CPU credits, it was at 100% of the CPU 100% of the time, it was actually very difficult to get into it and get our logs out. I ended up having to take a snapshot, make a volume, and pull the logs out by attaching that to another instance. And we didn't want to go through this again. If we run into application issues, we want to make sure that we have the ability to troubleshoot them. So we are going to go ahead and stream those logs directly to Claude Watch logs, where we can query them without going into the instance at all. Once we've got a little bit of operational readiness, at least we're going to have the ability to see whether or not this application is starting to crash out or enable the developer to start troubleshooting his own application and his own code. Then we want to start looking at security, because this is not something that's really been forefront in this relatively haphazard deployment here. And so we want to just cover our basic bases. The first thing that we'd want to do is install AWS Inspector to take a look at all the obvious security vulnerabilities, get an idea about patching. In this case, we had some security patches that we needed to apply to the instance. This happened prior to the launch of Guard Duty, but in modern day, you would actually also want to use AWS Guard Duty to take a look at the network traffic that was going on so you can start to see some unusual patterns. AWS Guard Duty is a security, a machine learning powered and compliance powered or configuration powered security awareness system, which will generate high value findings for you depending on what it sees in your VPC flow logs, DNS lookups, and CloudTrail logs. What I would be looking for in this case would be unusual callers, such as people connecting to the application via Tor, and also some unusual network activity going out of the instance. Because if this is an application that's only going to be receiving information, there's not a lot of reasons for it to start looking up Bitcoin addresses, for example. So after that, we had to generate a little bit more operational readiness. We realized that this was an application that had been brought down by traffic really quickly, and so we took a little bit of time and decided to bake a functional AMI out of this, and then we put it into an auto-scaling group. Because we had set up that metric and the off of Claude Watch, we were able to make the auto-scaling group expand out based on the CPU activity, and then we put a load balancer in front of it to further reduce the load on the application server itself. And finally, in order to get our disaster recovery environment working, because this developer actually had taken the time to develop all of his work in CloudFormation, we were able to simply take a copy of that CloudFormation template and keep it around for deployment into another region, which is essentially a cold DR environment that you don't need to get built for because the infrastructure isn't there, but which you have the ability to deploy at any time.
So you were able to operationalize faster, and you were able to recreate the DR environment faster than 12 weeks. Again, the AWS story here in this case for operations is faster, easier. I'm going to move on to our last scenario, and then following our last scenario, we've got a couple quick tech tips that Orion's going to share with you. So this is a rare story that I experienced in my on-prem life, and it doesn't really have a happy ending to it. You want to do CI/CD. You want to do the, you want some of that DevOps thing, and you want it in an on-prem environment. So we actually went down the path. You want all the best of what CI/CD and DevOps promises. You want environments to be able to be built or torn down automatically. You want the tear up and tear down to be restricted to what you want it to be done to, and not other stuff. So this story, what we had was, again, Shadow IT. I don't need to tell you what that is again, do I?
I mean, I have a short memory, but I think I got it.
Okay. So we went ahead and built a CI/CD environment on-prem using some software. And then essentially what happened was we neglected to address some of the security and permissioning issues, and as a result, we stepped on stuff. We broke stuff. I don't know if you've ever done this, but if you're not careful, again, your best intentions of let's do this for this app might end up breaking something else downstream because we didn't really segment or do any sort of due diligence about how we were going to separate these two things. We were careful about this because we were trying this DevOps thing and we wanted to maintain the momentum. So what we ended up doing in this particular case was we paused to try to figure out what it was that was going wrong that was making this not work and step on. And in my story, in this particular case, we never actually got it to work. I'm sure others have, but we didn't. So talk to me about how you have done this in AWS.
So if anybody remembers back in the days of yore in scenario 2, I talked about the fact that there was an IAM instance profile that was terminating an instance without a proper change management solution or any other type of governance. As it turns out, that was this CI/CD server. which had been spun up in the account without anybody really thinking about the permissioning model, without anybody really taking into consideration the other resources in the account. And as a result, it had terminated out other servers for other applications that it shouldn't have been managing. And that was a big problem. We got a big red flag from management saying that this really needs to not happen, and like maybe we're gonna have to separate you kids. And ultimately, we had to go and find a solution. And the solution here is actually pretty straightforward, and if anybody is familiar with IAM, you probably know where this is going. There's a system in IAM for managing this kind of permission called condition keys. And so how IAM permissions out more granular access is that you would say, I want the CI/CD server's instance profile to be able to submit the EC2 run instances API to launch new instances with one condition on it. And the condition is that it includes this tag, and the tag is the name of the application. Which means that it can't just run any instance. It can only run the instances so long as it associates that tag. And the important part there is not that it can launch the instances, although that is nice to keep track of what is being launched, but also so that you can give it the ability to manage the lifecycle of those instances. So not only can it run them, but it can also stop them, and then start them again, and then terminate them, and really do whatever it is that's necessary for it to manage its own CI/CD pipeline without me as an operations engineer intervening at all, because I shouldn't be. This is a code-managed system, and this is a piece of permissions management that AWS IAM actually enables us to pursue. Unlike my colleague Wallace here, I was actually successful in deploying this and washing my hands of the entire scenario.
So you used a combination of IAM, resource tags, and conditions to solve the problems that we were never actually able to solve in the on-prem space.
Oh, and also another nice thing that managers were pretty happy about this time around was the fact that we weren't leaving up a bunch of test infrastructure that was only going to be used once per sprint by the dev team. We could spin it up when they needed to run their tests. They could run as many stages as they wanted without considering the fact that there's going to be a bunch of additional infrastructure costs, because the infrastructure itself is only going to last for the duration of the tests, which is usually, some minutes, maybe an hour.
Cool.
Yeah.
So that's the end of our scenario-based discussion. What I asked Orion to do is come up with some, I really challenged him here, come up with some tech tips that would be really hard to find in either blogs or training or something like that. So we came up with these, so talk to us about these.
Yeah, so the first one is the first thing that I ever did in AWS that I actually thought was clever. I found myself spinning up and down a lot of infrastructure really fast. I was hopping around between things, and I was running into situations in which I had, 300 character, 15 semicolon commands in bash that I was loath to lose, but in fact did when I terminated that infrastructure because it was no longer needed. And it turns out that you can actually just stream it into Claude Watch logs. It's really, really nice to have this record of everything you've done there, and it's also a good auditing tool for if you want to know, hey, who did what in this instance, you can have a record here. It's obviously not that difficult to circumvent. If actually somebody wants to get around it, they can just disable the log, but it's really, really nice if you're trying to keep track of what it is that you're doing. The second one is something that I've had a couple of situations in which I found it very useful to restrict access to the IAM instance profile. And I'm going to go into how that works really quick. IAM instance profiles and resource profiles are managed by something called the EC2 metadata service, which is something that allows the instance itself to communicate to a essentially null address space in the 169.254.169.254 address, which will serve a certain amount of information. And one of those pieces of information is IAM credentials, which will allow it to take whatever actions that you've enabled in that instance profile from the instance itself without storing static credentials or anything like that. Now, this is really nice, and sometimes you want to have these profiles extant on the instance, but maybe sometimes also other people are going to log into it, or it's used as a bastion, or any other thing may present itself as a particular security risk for you, and so you want to lock it down a bit. You can actually use IP tables, or in Windows, you can use the Windows firewall to restrict the access to this, not just by IP address, but also by the user ID. so that only root can access that, which is really handy if, say, you have a bunch of permissions you want to grant during boot time, but not later on. And then finally, again, using the EC2 metadata service, IAM is not the only thing that's served out of that service. There's a lot of metadata about your instance, including network adapter information and other useful data. I've found myself writing a lot of scripts that are specific to Fedora or Ubuntu or RHEL or what have you. And then just because little commands function a little bit differently in the different distributions. And at a certain point, I stopped doing that, and I started just curling the metadata service to get that information because I knew that that was going to behave the same way anyways, because it's all the same platform. Yeah, those are the 3 tech tips.
Awesome. All right, so I put together a slide as some key takeaways. I'm not going to bore you with reading through them. These are some key highlights. If you're going to take a picture, this is the one. These are some things that we talked about. It has to do with using a bunch of services, some that are not necessarily geared or directed towards operations. Don't forget to turn these on. Don't forget to enable their access or disable it, however you want to do that. So with that, 2 things. I want to thank you for your time. Very much appreciate it. There's a survey for the session. We're interested in doing this on a more frequent basis. If you found that this was interesting, please use the survey to tell us that. But also, if there are either scenarios or services or other things that you think might be interesting to cover in this kind of scenario-based learning, please drop a note in the survey. We're going to make a pitch when we go back to do, I don't know, we're thinking like monthly videos or something. I don't know what it'll be. But something so that we can get this out more frequently than once a year. So I would like to ask you to do that. There's a related session that I just wanted to flash up here for you. As a reminder, if you find the enterprise DevOps thing interesting, search your catalog for that. There are a couple sessions on that. And you should tell all your friends and your colleagues that there's a repeat session of this on Friday morning at 8:30. So they got to be interested, and they should not go to the party on Thursday night to be at the Venetian by 8:30. We'll be doing this again. So with that, thank you very much. We'll be out in the hall if you have questions.